So welcome back. In this video, we will discuss about the concept of disinfection in the water treatment system. Disinfection means reducing the number of microorganisms present in the raw water. We also use sterilization as synonym to that. The sterilization usually referred to killing all the microorganisms in the water. Now you can see here in this picture. This picture you can see here. Now you are having a pot of water, having a lot of microorganisms. Now you are adding some disinfectant. Then you can see all the microorganisms are destroyed and you can safe to use. And here also you can see this another picture. The lot of microorganisms are present. And when you're after adding disinfectant in the water, this is the number of microorganisms. You're adding disinfectant here. Then ultimately what you are seeing, the number of microorganisms, they are reduced in the number. So this is the fundamental concept of disinfection. The mechanism you can see here, when you're adding a disinfectant, it should give a damage to the cell wall mechanism. It should alter the cell permeability. It should change the nature of cell protoplasm. It should inactivate the enzyme systems responsible for the metabolic activities. So disinfectant should be capable of destroying the cellular activity, and it should inactivate the fundamental system of the microorganism working. So that is the main thing here, the mechanism part. The suitability, if you see, the disinfectant it should be used, it should be effective in killing the microorganisms within the contact time. It should be effective over a wide range of temperatures. It should be readily available at reasonable cost. It should be safe to handle, easy to apply, and it should not render water toxic. It should have a residual concentration to persist its effectiveness in the longer duration. And that, what is this residual concentration? We'll see. That some of the different methods of disinfection, if you look at here, what you are seeing, there are classified as physical methods as well as chemical methods. So physical methods means boiling. This is a normal household operation where you keep the water in a container and boil it. So bacteria or microorganisms cannot survive at high temperatures. The other method which are used in the rural areas, in the tribal areas, particularly is the solar disinfection method. Is also called in short as a SODIS method. SODIS stands for solar disinfection. So what you are using is you are keeping the water in a transparent bottle, now preferably a plastic bottle, and you expose that to the sun, and the sun rays will pass through. The ultraviolet rays which are present here in the solar radiation will disinfect and it will disinfect the microorganisms present here. And after some contact time, you remove that bottle and then drink it. The water is much more safer. And artificially, it adds a lot of chemicals, the method called chemical methods. We will be using ozone to destroy these microorganisms. Silver and copper ions, they are being used for centuries now. Lime is a good disinfectant. Potassium permanganate is used at some places. Hydrogen peroxide is also used. Chlorine and bromine. And chlorine is predominantly used and bromine is occasionally used. Now you see here, when you're using chlorine, we are making a solution with the chlorine and then you're keeping in a contact tank, and that information is, you can see here, the filtered water is going out from the contact tank. Excess lime treatment, what you're seeing is lime is added to the water to raise the pH to greater than 9.5, where E. coli will not survive. Efficiency is up to 100%. Dosage is 10 to 20 milligrams per liter as dry lime CaO. Excess lime should be removed before the usage because it gives a bitter taste. It should be removed using a recarbonation. And then that excess lime is through different methods. Silver treatment, silver particles are deposited or activated carbon and are introduced in water, uh, which disinfects the bacteria. Dosage is very small, 25 to 40 ppb with a contact time of 10 to 60 minutes. Here, as I mentioned, the dosage and the contact time both are important. If sufficient contact time is not available, the disinfectant may not be able to destroy the microorganisms. If the dosage also is not sufficient, then the effectiveness will be reduced. Because silver is a high cost material, so is not used for large applications, but only used for home practices. Ozone treatment is there. Ozone is a powerful oxidizing agent, which when dissolved in water produces a broad spectrum biocide that destroys all the bacteria, viruses, and cysts. Ozone oxidizes the organic material in bacterial membranes and weakens the cell wall, leading to cellular rupture. So this is the advantage of using the ozone. So usually it is artificially prepared. It oxidizes iron, manganese, sulfur to form insoluble metal oxides. The concentration is around 1 to 2 milligram per liter for a contact time of 10 minutes. Now another thing is you can see here ultraviolet treatment. Ultraviolet rays are artificially generated using mercury vapor lamps enclosed in a quartz globe introduced to the raw water. So you can see here, this is a small bottle here, small enclosure where ultraviolet rays are artificially produced. Now allowing the raw water to enter here, they will come and they get exposed to the ultraviolet ray here, and subsequently after disinfection, water is taken out. So what you see is a narrow tube here. Depth of water should not exceed 10 centimeters. That's why the tubes are narrow here. And the limitation for the turbidity. It is also a costly method. It requires some electrical power. So that's why used only in the home treatment systems and swimming pools, apartments, institutions. Potassium permanganate is also used at some places. At some places, it is also used. Is where KMNO4 is dissolved in a bucket of water and is mixed in well water. It not only kills bacteria but also helps in oxidizing organic matter in the water. Contact time is around 4 to 6 hours and dosage is around 1 to 2 milligram per liter. But drawback with this method is this potassium permanganate gives a pink color treated water and it should not be used for the first 48 hours. Then another thing we should understand is chlorine is very good disinfectant. When it's mixed with water, it converts to hypochloric acid and hydrochloric acid, hypochlorous and hydrochloric acid. Hypochlorous acid again ionizes to hydrogen ion and hypochlorite ion. So the combination of hypochlorous acid and hypochlorite ion, they are responsible for overall disinfection of the microorganisms in the water. Now you can see these two are pH dependent. What you notice here is this blue color HOCl is occurring mainly at a low temperature, low pH value below 8, below 8 or below 7. You can see maximum is present. During that pH, the OCl minus is availability is less. And what is more important is here, HOCl is more effective than OCl minus. So we try to see, to get more efficiency, we try to see that the pH will be in the range of 6 to 7 or 6 to 7.5, where more HOCl is available here. So now if you look at the diagram and the conclusions are drawn, at pH 5 to 10, both HOCl and OCl minus are present. At pH greater than 10, only OCl minus is existing. At pH less than 5, chlorine exists only as elemental chlorine. So that is not our concern. Our concern is only between the 6 to 7 or 7.5 pH range. So where the effectiveness is more due to the availability of HOCl in abundance. Some other terminology are also there. Chlorine demand. When you add some chlorine, it will undergo some process of disinfection, and finally it is available in the form of residual. So how much is added, how much is utilized, that is the chlorine demand. Difference of these values is nothing but the chlorine demand. So you can see here, chlorine demand is nothing but chlorine used minus whatever is left over. If 10 milligrams of chlorine is used, only 8 milligrams is converted for disinfection. 2 milligrams is left over, that is your residual chlorine. And we are having some other terminology here. Combined chlorine, amount of chlorine that has reacted with the nitrates. Because in the water, they're having number of impurities. You're having inorganic impurities, organic impurities, nitrates are also present. Chlorine reacts with all these things and convert into corresponding chlorides. So ammonia nitrate compounds converts into ammonium chlorides, and then organic chlorides, inorganic chlorides. So whatever it is reacting with the nitrates, which is not available for disinfection, is called as combined chlorine. Free chlorine is nothing but the chlorine that is available to inactivate disease-causing microorganisms in water. So combinedly, we are calling as the total chlorine, which is not available and what is available. Free residual chlorine is nothing but, that's why it is also called as free residual chlorine, remaining after fulfilling the oxidation of the impurities. A residual chlorine is maintained as 0.2 milligrams per liter after contact time 10 minutes. The contact time usually adopted in all the water treatment systems is where chlorination is used 10 to 20 minutes, preferably 10 minutes. So here 0.2 milligram per liter, it should not exceed the residual chlorine. So why it is used and why it is importance? After the treatment is over, the treated water will be sent through a distribution system to the cities and towns for the public uses. So there is a possibility that during the travel in the pipes, some microorganisms, new microorganisms get added in the treated water. So some chlorination must be given to destroy even the minutest part of this microorganisms added in the distribution system. So what are the residual chlorine we are maintaining that will help in destroying that extra microorganisms in the distribution system? That's the reason why we maintain the residual chlorine.